All right, number 12, we have a function here, g of x equals x plus 2 sine x. And our objective here is to figure out where does this have horizontal tangent lines. So remember that a horizontal tangent line is a tangent line that has slope 0. And remember that the slope of your tangent line is determined by the derivative. So this is asking you, where is the derivative of this function equal to 0? And notice that since we have a trig function but we were not given a restricted interval, this didn't say, for example, on 0 to 2 pi, that our answers to this question are going to be general formulas that are going to involve a infinite number of rotations for the trig function. So we need to find the derivative and we need to set it equal to 0. So the derivative here should be pretty simple. There's nothing real special about these functions here. The derivative of x is 1. The derivative of sine x is cosine x, and it's still multiplied by 2. So our derivative is just 1 plus 2 cosine of x, and we want that to be equal to 0 in order to find the horizontal tangent line. So let's solve then for cosine. We can subtract 1 and divide by 2 to get that cosine of x has to equal negative 1/2. So every time cosine of x is equal to negative 1/2, we get our derivative to be 0, which means we have a horizontal tangent line. But there are many, many places where cosine of x is equal to negative 1/2, especially if you don't have a restricted interval. In fact, we have an infinite number. So we need to figure out what that is. So the easiest way to do this is to just say, where is the standard rotation answers for this? And then we're just going to add 2 pi to them. So let's think about where on our standard rotation 0 to 2 pi, where is cosine of x equal to negative 1/2? Remember that cosine, using our ASTC to determine which functions are positive. Cosine is positive in the first and fourth quadrants, so it's negative in the second and third. So we need second and third quadrant angles. The reference angle for cosine of x equaling 1/2 is pi over 6 in the first pi over 3 in the first quadrant. So essentially this is asking us, what is the same angle as pi over 3, but in the second and third quadrants? So that's going to be 2 pi over 3 and 4 pi over 3. So those are our two values on our standard rotation where cosine of x would be equal to negative 1/2. But now, like I said, we don't have a restricted interval in this problem. We want all possible horizontal tangent lines. So you can see that if the cosine is equal to negative 1/2 somewhere, then if you went all the way around the unit circle again and came back, it would be negative 1/2 there. And you could go around as many times as you want, or you could go around the opposite direction. So what we have to do in order to make this correct is we have to say that you can add or subtract any multiple of 2 pi to either of these answers, and it'll still be correct. Remember that adding 2 pi or subtracting 2 pi always creates the same angle. So what we're going to say is it's 2 pi over 3 plus or minus 2n pi. Same thing for 4 pi over 3. And this is where n is 0, 1, 2. So n is a whole number. Alternatively, you could just say plus 2n pi and say n could be negative numbers also. So this is saying you can have any multiple of 2 pi added or subtracted to these, and that will give you all the possible horizontal tangent lines of this function.
The Teaching Center, UF's Learning Resource Center.